Whoa. Yeah. Well, hello everyone. It works? Yeah. We will start to warm up with a technical presentation, so please try not to fall asleep. Let me introduce myself. My name is Konstantin Dovnar. You can call me Kostyan, because we're almost friends here. And who am I? Well, currently I am a developer with a bunch of experience, mostly of them in mobile development. Right now I am a Flutter tech lead at Yandex Pro, and my responsibilities is performance, observability, and network. So this is how we made up this presentation about network. Also with me here is Ringy in the core. They will help me to explain some part of presentation to you. And you could ask me you could ask me, what is Yandex Pro? And I will try to explain you. Yandex Pro, it's actually a dark side of Yandex Go. Yandex Go, it's a beautiful application that help you live better life in the city. You can order a taxi, order a delivery, something like this. And Yandex Pro, it's an application for people to the other side who can grab your orders and, well, complete them. And our application is kind of special. Here's what I mean. For example, one of the most popular applications in the world is TikTok. And an average session in TikTok, it's around 10 minutes. For YouTube, it's about 14 minutes. But for Yandex Pro, it's 3 hours. That means that users open application and use it 3 hours in a row. And of course, all this time, our application is, well, kind of busy. One of the things that we do is bunch of network communication. So we need to optimize it somehow because, well, we want to make it efficiently. So what we'll talk today about? About the problem itself, why does this problem even exist, and what we can do about this. So let's move on. The problem. Actually, the problem look like this. And if you don't know where to look at this letter E. This letter indicates that your phone currently uses a second generation of the mobile network. And with this, there's happened a bunch of not very well things. Something like this infinite loading. And I'm pretty sure that if you stuck with something like this, this will be your reaction. No one loves infinite loadings. But some of you could say that there is no such a problem as a old generation of the mobile networks, because everyone sits on the LTE or even 5G. But this is not actually true. And here's some proofs. Here's the map of beautiful city Samarkand, and here's a heat map of requests made by Yandex Pro users in the bad generation of networks. You can see that even in the middle of the city, there is a bunch of requests made in the second generation. Here's Tashkent, and here's heat map for it. You can see that in the city itself, there is no problem, but there's a problem around the city. But people still live there, people want to use your application, and, well, we need to adapt for it somehow. And if we talk about worldwide application like ours, like Yandex Go, Yandex Pro, there's a problem everywhere. For example, Lima, capital of Peru, Islamabad, capital of Pakistan, or even Abu Dhabi, one of the modern cities in the world, still got this problem. But actually, bad network communication, it's not only about bad generations. It could happen anywhere. For example, with poor coverage, overloaded servers, or closed space, it could happen anywhere. So keep in mind that all optimizations will help everyone, not only users in the bad generations. But why does this problem even exist? Let's think about it a little. First of all, it's radio resource control. Radio resource control, it's how your phone works with the network, how your network chip actually work. It could go through a bunch of states to make it more efficient for your phone and for your battery, but we care only about this state. The problem is that waking up your network, it's pretty expensive operation. Here's the number. You can see that for the old generation, it could take few seconds just waking up your network. And even for the modern generation, it still could take hundreds of milliseconds. Not very efficient, if you ask me. The next thing, it's round trip time. And this is actually how long you need to take to send some packet of the data to the server and get your response back. If some of you play video games, something like Team Fortress 2, maybe Counter-Strike, Dota, anything, you should know something called ping. And ping, this is actually a synonym for the RTT. So if you get a big ping, you got a laggy game. And here's some average good value for RTT. Again, you can see that for the old generation, it could take hundreds of milliseconds just to send some data and get response back. That's not very efficient either. And the last problem, it's packet loss. What is this? Actually, when we're sending some data, we always send it via packets. It's happened under the hood. You don't think about this, but at some point when we send our data, we could lose some packets, and this will affect your network communication in some way, based on how you work with the network. And here's some average percents for the different generation. Again, you can see that for the second generation, it's not very well, but it become better for new generation. So let's made up a path of request in the second generation, just to understand how bad it be. Well, first of all, we need to wake up our chip, wake up our RCC. Then, of course, we need to make a DNS request. After this, we need to make a TCP connection because, well, HTTP works above TCP. After this, we need to make our connection secure, so we need to make a TLS handshake. And only now we could send our application data, something that we want to send. So 2.5 seconds only just to start sending data. Not very good. And even in the fourth generation, it will take half a second. Bless you. So what's about this? The problem is that everything I showed you before, it's something that we can do nothing about. And the good part here is that our phones is pretty smart, and they do a bunch of things here. But let's talk about what we can do to make it better. So keep in mind the main thing. Less data is better, always, when we talk about network communication. Here's how it works. For example, we've got two packets of the data. One is the small one, another is the big. The small one could send by only one RTT, if it's small enough. But the big one will cut into the pieces and send one by another. So it will take few RTT to send this data. So the first thing that, well, should go in your mind when we talk about making our data smaller is compression. Is there any backenders in the room? Yeah, cool. So please, backenders, raise your hands if you're completely sure that your responses that you sent compressed when they, well, send back. Okay, cool. So please, dear backenders, implement compression because you can do it very easy. Here's how you do it with gzip for nginx. Only a few lines of code, and it could dramatically make your responses better for your users. Okay, now here's some mobile developers. Raise your hands, please. Yeah, cool. And please, mobile developers, raise your hands if you're completely sure that your requests compressed when you send them. No hands, and it's completely fine, actually. Why is this fine? The reason is that there is no such mobile network client, and, well, network client at all, that compress the data out of the box. And the reason for this is pretty simple. When we try to send some data, we know nothing about backend. So we cannot be sure that backend can handle compressed data. So what you should do here, actually, you should make a contract. You should go and say to each other, so since today, we start to compress requests and responses and can handle them. That's all. But how you should compress the data? Let's talk about algorithms a little bit. Here's the three mostly popular algorithm, but of course in the world there is much more of them, but this is something that you will be stuck mostly. So gzip, this is pretty old algorithm, but still good enough. It works very well, give you good compression, supports everywhere. This is the main benefit here. So you should stick with gzip if you can't or maybe don't want to use modern algorithm. And if you can use modern algorithm, look at Z standard. This algorithm work much more efficiently, have comparable or even better compression ratio, and have, well, it's actually have some other features, but we have no time to talk about them actually, so you could catch me later to talk about this. And then come broadly. Broadly, it's actually pretty special algorithm because it took much more time to compress the data, but give you better compression ratio. So you should use it for some big resources, something like big HTML pages, translation sets, static resources, all that stuff that you can compress once and use to all users since then. But what about us? And by us, I mean Yandex Pro. When we talk about, when we talk about responses, I actually have nothing to tell you because we compress the data since, I don't know, since I was like this, so things just fine. But what about requests? We start to compress the requests not too long ago, and before we did so, there was 0.1% of requests with payload that completes faster than 100 milliseconds. Not very well. So what we did, we implement simple gzip for any payload more than 1 kilobyte, and this percent raised up to 15%. Well, pretty good result if you ask me. There is a photo of me when we saw the result. Here it is. So I was really happy, and should be you. Start to compress your data from both sides, backend and client. But why do we even need to compress the data? The reason is pretty simple. Here's the JSON. When you look at this, I'm pretty sure you already understand what is this. And this is the problem. This is the text format, and this is very well for the human, for us to read, to understand, but not very efficient for computers. So here we will talk about protobuf. Protobuf is actually a data protocol that works as a binary data. Again, same JSON, and how the same data will look as a protobuf, like this. I am pretty sure that you look at this and can't understand nothing here. But believe me, your computers, phone, or servers, anything, will say thank you. So what we did in Yandex Pro, we did an experiment that we call a shadow call experiment. And how it works. We've got our client, our server, and regular JSON requests. So we implement the mirroring requests that start to work with proto data. And, well, measure it in any way. And we got pretty good results. Here it is. First of all, out of the box, the size of requests become twice smaller. Pretty good. With the same data, I remind you. And of course, because size becomes smaller and decoding and encoding become faster because protobuf work faster, we've got better latency. Again, we want more than 2 times just by using protobuf. So, still, I'm pretty sure that protobuf is not for everyone. There is a bunch of costs. It's much more complex. There is no such great tooling as for simple JSON. You need to work with proto contract and all that stuff. But you should use protobuf in the cases, well, actually in 2 cases. First, if you have some high-loaded endpoints, you should use with them. Or if you use gRPC. Because you have no choice, gRPC works above protobuf. So the next part is media. Why we talk about the media? Because it's some part of the network communication that could drain your network completely. So here's the photo. The photo of Kitty, actually, it's my kitty. If you ask me, her name is Glasha. And let's pretend that I want to send this photo to someone, but I am currently in the 2nd generation of network. Let's do a simple math here. The original size of the photo was more than 2 megabytes. Here's the upload speed for the 2nd generation. So if we do a simple math here, we will understand that sending this photo will took 3.5 minutes. Just sending photo and nothing more. And even in the 4th generation, it will take 1 and 6 seconds. not very efficient either. So, what we should do in here? Actually, when we talk about the media, always adapt to your needs. This is the main thing here. When I want to share this photo, I don't want to send the original one. I just want to quickly show someone how cool my kitty go into the box. So what I did here, first of all, resize the picture. I don't want to send the 4K. Then I use much better data type WebP. Then I, of course, compress it, because compression is the big boss of optimization. And we've got the same picture, but smaller, and much smaller in size. We want more than 93% here, just by making our photo, well, adaptive here. So with new size and the same speed, it will take only 16 seconds to send this photo instead of 3.5 minutes. And in the 4G, it will take about 100 milliseconds. Very good if you ask me here. So we want more than 10 times, of course. It is pretty good. But again, adapt to your needs. And I mean it by any media type. For example, here, how it works with picture. Big players work with pictures. They use JPEG, compress it, resize to smaller size, but it still look good enough in your phones. For the music, again, they use not very big bitrate, mono sound when they can, and all that stuff. And video. And here's actually, raise your hands if you use Telegram. Yeah, and I'm pretty sure you know what around video messages. Here's, you can see that they pretty small. They got small resolution, small bitrate, but they still look good enough. You see all the details, you can understand anything that happened, and they took much less space than if you use the original one. So, here's the short part about user experience. Well, first of all, try to cache everything, because when you cache something, you don't need to load it again. Pretty good. When we talk about timeouts, just make your timeouts, well, large enough. Here's the numbers from Yandex Pro itself. You could adapt this. And when we talk about retries, do not make infinite retries. Retry few times and stop it. And always use exponential backoff, because this will not only help your users, but also will help your backend, because your RPC will not go in the sky. And always be honest with your users. If there is a problem with network, say about this. If there is a problem about your backend, say about this and stop sending requests. So here, kind of technical part. TLS, transport layer security. This is actually how your HTTP become HTTPS. And in the security happened a bunch of things here actually. But we care only about these two. TLS 1.2. It's strong baseline. It's got a pretty good algorithms for your security, but it's not very efficient when we talk about the network communication. So here's come TLS 1.3, and this become much better. This gives us a bunch of benefits, but we care again about first and the second one. 1 RTT for connection and 0 RTT for reconnection. Let me explain this to you. Here's the path of request in the second generation. We talked about it before. And there is a part of TLS handshake. This is how we make our connection secure. TLS 1.2 take 2 RTT just to make our connection secure. You could see that for the second generation, it will take the whole second just to make it. But with TLS 1.3, without changing anything, it will take only a half. Pretty good. But if you use a reconnect to your services, it will take none here. So you cut the whole step here just by using the modern algorithm. So please go and enable TLS 1.3 for your users. The best part is that you can fall back for the TLS 1.2 if there's a problem with the new version. And here's how you can do this with, again, with Nginx. Please go and do this. This is pretty easy. And now let's talk about HTTP. Well, first of all, there was a first version of HTTP. Old but gold, as I say. It was pretty simple. It was text-based protocol, works everywhere, but got a bunch of problems. Head-of-line blocking, for example, we will talk about it a little bit later. And it create a new connection for each request. That's not efficient at all. So there become second generation of HTTP, or problem solver. And this gives us a bunch of benefits. It's become multiplexing. That means that you create one connection and start to send each request through it. It's use HPAC. It gives you ability to compress your headers. It's become binary, so it's much more efficient for your computers. And actually, I don't know why I put here priorities, because I have never seen in my entire life that someone implemented and use it. But okay. But of course, there is a problems. First of all, it's TCP head-of-line blocking. Again, we will talk about it later. And complexity. HTTP 2 become HTTP 2, sorry, yeah. HTTP 2 become much more complex as a standard, so it's much more complex to work with. So here become HTTP of third generation, or the new foundation. And by saying new foundation, I mean it, because it starts to use UDP instead of TCP as a transport. And this gives us a bunch of things. One RTT for the whole connection, including security. 0 RTT for reconnection. No head-of-line blocking at all. Again, we will talk about it a little bit later. Built-in TLS 1.3, so any connection is secure out of the box. And connection migration. So let's focus on connection migration. What is this? Opa. Okay, sorry. What is this? Yeah, let's pretend that there is no cross right now. We've got our client. He sits at home, drink some, I don't know, maybe Coca-Cola, eat some snacks, and use your application through the Wi-Fi. At some point, he needs to go outside, and he reconnect to the mobile network. And just because how HTTP of the second generation work, your connection will be disposed. This is just the part of standard. We can do nothing about this. But what happened for the third generation? Again, the same scenario. User go outside, but connection still fine, because actually UDP have no connection, and this is work without it. And now about head-of-line blocking. What is this? We talked earlier about packet loss, and at some point you could lost some of your packets. Sorry, it could happen by any reason. And with TCP, that used by HTTP 1 and 2, if you lose some white pocket, I don't know, sorry, packet, of course, you can't continue until you resend this packet. This is just how TCP works. So let's see how it affects our HTTP. Well, in the first generation, we've got our client, our server, and clients start to send few requests at the same time. And if there is a problem with one of the requests, for example, with the second one, the first and third will continue fine, but the second one will wait until this packet will resend. It looks like actually like a line in the mall. If there is a problem on one cache registry, it will stuck, but all another will work fine. When we talk about HTTP of the second generation, because it's become multiplexing, we reuse the same connection for each request. So what happened if we got a packet loss here? It will block entire connection here until we resend it. Sound terrible actually, but this is not a big problem. Don't care about this. This is just how it works. And this looks like this. Some traffic, and if there will be a problem, something happen, some crash, for example, in the 4 lines, then everything will be blocked. And what happened with HTTP 3? Again, it's multiplexing. We got a problem with one of requests, but because it's UDP, we don't care. We just keep sending each packet and try to resend it when we can. So it's more like our beautiful rovers, and I'm actually have a spoiler for you. I hope they will arrive in Uzbekistan in the next year. They pretty smart. They go around the blocking in front of them, and pretty cool. So HTTP 3, it's much better on the mobile network actually, because on the mobile network there's a bunch of problems. It's took less RTT to work. It's got no head-of-line blocking, less stall. For example, here are numbers of Kiwi. Kiwi did a good research about HTTP of third generation, and they counted the same request made by HTTP of the second generation and third generation will took, well, dramatically different time, as you see, if your user get a packet loss. Here's, for example, not for example, just a QR code if you want to read it by yourself. And, okay, let's scan it. I didn't expect you will be so interested in it. And of course, with HTTP 3, there is a bunch of trade-offs. The main of them is CPU, actually, as I think, because, well, just out of the box, HTTP 3 took more CPU. And this is not very well, but something that we can work with. But what version should you choose as a developers? Actually, all of them. Do not stuck to one version. What you should do, you should use HTTP 3 if you can use it. If you're okay with the CPU overhead, if you can use UDP, all that stuff. If there is a problem with HTTP 3, you can still use HTTP 2. It's multiplexing, give you benefits, all that stuff. And if there is a problem with either of them, you should go with HTTP 1. And you should just give your user ability to choose what they want to work with. So actually we've done here. And each presentation should end with something smart. So let me try, say something smart here. Well, first of all, bad network is a baseline. Do not think that bad network happened to small % of users. No, it could happen to anyone, anywhere, anytime. Of course, the best byte is that the byte that you not sent. So try to make your data small as possible. Or try to not send something if you can not send it. And of course, network optimization is a team effort. Please work as a team. Only backender can't optimize it. Only mobile can't optimize it. We need to work together. So keep this all in mind. And here's actually a slide for a photo. What you should go and do on your job on the Monday. Or if you want to, of course, maybe you're not. So you can make a picture of it and go to your team lead, product manager, someone, and tell, let's do something from this list. So, actually we've done. One moment for the picture, yeah, I see. Okay. Of course, with me here, Ringy and the core, and I ready to, well, at least try to answer some of your questions if there is.